Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here unit number 3, manufacturing. So in that content we are going to discuss the understanding CNC and basic part programming for milling operation. So first of all we consider these points. So first point is the CNC machine. Second point is history of CNC. Third point is components of CNC. Fourth point is manual part programming. Fifth point is creating toolpath in CAM environment using Autodesk Fusion 360. So first of all, we look at the CNC. CNC is nothing but computer numeric control, or you can say it is a method of automating a control of machine tools through use of softwares which is embedded in a microcomputer and attached to the tools. So here the CNC has a language, so that called as International Standard Language, and it should be proprietary code and miscellaneous code which is stored in a machine control unit, and according to that it can perform a work that should be continuation from that program. So that program contains instructions, and with the having some data, that is feed rate, speed rate, then positioning of this tool, then speed of the tool. So this is the containing data, so we can include in a that program, and this program is fed to the MCU unit. So according to that, that should be performing operations. So the automated CNCs with mills, lathes, routers, and laser cutters. So these are the tools, automated machine tools we can use over here. Now we discuss regarding the history of CNC machine. So as you know that in 1945, so this is the manufacturing the initial state for the pull cart manufacturer. After that, it should be versionized to the 1984, 1953. So that should be used for aerospace and machining for the markets. Now in 1979, it should be evolved in a aerospace as well as defense market. So after some evolutions, it should be increased to the 1995. So that should be specified for the aerospace, defense, and government programs. So after 2013, it should be creating a precision machining brand. So this is the evolution stages regarding the CNC. Now next step, you can study the components of CNC. So from the import devices, we can give the data from to the MCU. So it contains the instruction sets with containing of the G code and M codes. So after that MCU, it should be containing the processing units, and it control the machine tools. So therefore the driving system will be run out according to the loop of the part program, and after getting from the feedback system from the machine tool, so it controls the unit by the control loop, and therefore the functioning will be takes place. So here the machine tool contains different parts. So for milling machines, different machine tool is here. For that, end mill is there, mill cutter is there, end mill cutter is there, ball mill cutter is there, hollow mill cutter is there, then thread mill cutter is there, hobbing cutter is there, dotted cutter is there, slide and face cutter is there, face mill cutter is there, involved gear cutter is there. So number of cutters is available with us, so we can use it, and we have to continue for the milling machines. So this is regarding the components of CNC. Now next part we will discuss regarding the manual part programming. So in that content we have to discuss the coordinate system and regarding the manual part programming. So first of all we look at this component drawing. So this is the component drawing. We are required final shape. So this is the your stock. So this is stock actually, and here we have to machining it and convert into this finished product like this. So this is your finished product. So after giving the G code and N codes to the system, so for that purpose we have to create a interpolation. So here this circular part is there, so that time it is called as circular interpolation. If it is tool is in that moment is straighter one, that should be in a so that linear interpolation. So here also linear interpolation, but after that what will happen, circular interpolation is there. After that should be linear interpolation, and after that linear interpolation. So this is the content of that interpolations. So first of all we'll look at the manual programming for this. So before that we will discuss regarding the that work coordinate system. So here the vertical spindle machine is there, numerical control mean is there. So on that direction, that is called as X positive and Y positive. So here tool is in a Z direction, and X and Y it should be move table, and Z plus. So if the tool is in a were holding devices, that time Z is positive, and if it touches to the workpiece, that should be called as a Z minus. So like this. So whenever their part is in a stock part is in X and Y positive, and if the tool is movement uh, a downward direction, that should be contain a negative directions. So here this is the stock, and here we are placing the Z direction. So Z direction means that tool direction. So when tool is come in contact with this workpiece, so that time it should be contain a negative Z, that is negative Z. Okay. So when you are mentioning the coordinate system, that time you can contain negative when it is touches the workpiece. Okay. Now this stock is containing like this. Now we eval for this direction is called as X positive, like this X positive over here, and perpendicular that we can consider as a Y positive, like this. So Y positive, and tool movement is about Z directions. So this is regarding the work coordinate system. Now we move for, this is the final product. Now we move for the manual part programming. So here I mentioned these points. So this point is A, that point A is called as 0 0, that is called as workpiece setting. Okay, and after that it should be moved to the B point, then after that it should be moved to C point, then up to D, E, then here circular interpolation is there, after that F, then G, then H, and after that last is the that circular interpolation is there. So this is regarding the manual part programming. So this is the interpolations we are know. So again I repeat, for circular interpolation it contains arc like this, and for linear interpolation it should be in a straighter manner. Okay, so first of all we look at the one first operation, N001, that is your sequence number, G00, that is rapid towers, G90, G90 means that absolute programming, and Z10, Z10 means your tool will be approached at uh, above, so above of this point. That means if their workpiece is there, so above that it should be 10 mm offset, that means 10 mm gap is there, and your tool is approached over there. So that is called as Z10, that should be is called as the positioning of the tool. Okay, so here tool positioning is at Z10. G00 means preparatory code, that should be contained a rapid traverse. G90 is nothing but your absolute programming. So this is regarding the sequence number 1. You can say N001. Now next N002, that is sequence number 2. G00 rapid movement is there, and X0Y0. So X0Y0 means here. Okay, so point A is called as X0Y0 here, and Z is about 10. So Z is about 10 mm above, that should be called as offset. And here spindle speed we can take 500, then M3, that means spindle start in clockwise direction. So this is regarding the block number 2. Then after that, from point A, so point A means X0 Y0. Now point will be moved to the point B, so this tool will be moved to the point B. So what will be B? So we identify this, otherwise we can take the dimensions here. Okay, so here x20, because the diameter is 40, that means A to B, that x distance. So here we consider x-axis, and here we consider y-axis. Okay, here y-axis, here x-axis. So horizontal direction is called as x-axis, and vertical you can say y-axis. So when your tool approach from A to B, that time x becomes 20. So that's why I write x 20. G00, that means what? G00 means your tool will move in a rapid direction, that is G00. So that's why x20, y is 0, because if you take this point as a 0 0, that's why this along the line the y will be 0. Okay, now next block, that is fourth block, that is G01. So tool will be actually at the Z plus 10, plus 10 means it is having some offset. After that it should be goes down, that is Z minus 20. So that tool will move downward direction. So that tool move downward animation means -20. So that should be tool is in contact with workpiece. That's why we can write -20. Why it is right +10? Because their tool is not contact with the workpiece, but here the tool will be contact. That's why it goes down and -20 is there. So 10 mm cut will be there. Okay, because +10 is your upper side offset and -10 means it is contact with workpiece. So this is about the this point B. Now tool will be move in a C, direct C. So what about the distance X? So here 20 is there, right? And total distance 100 means C at a C point X value is 80. So I can write here N005 G01. So G0 means 1 means in linear interpolation, and that reach point at X80. X80 means the point tool will be reaches this point. Okay, so that's why I can write X80. Y is 0 because Y is at a perpendicular direction, but it is live in a x-axis. That's why I can write Y0. So now tool will be reaches at point C. Now this tool will be moved to the D point. So for the purpose, we know that this is linear interpolation. So I write G01 and X is complete distance, that is 100, right? So this point X is 100 and Y is 20 because Y is 20. So I write X 100, Y 20. That's why the tool will be reaches from C to D. So this is regarding the tool reaches at the D. Now tool D moves to the E. So what is the value of this for Y? X is, what about X is from this distance X is 100 and Y is about what? So here the tool radius is radius 20, so we can 20 is there, so 80. So here the E point is at 80 for Y axis and X is 100. So that's why I reckon write N007, and we can write here this is the X100, this is X100, and this Y base to be 20. Okay, so that 20 will be reaches. Now we move for the cutter, that is the N007 G03. So now this tool will be reaches to this point, and here we can go to circular arc. So I can write X80. So X80 means this is your start point, and Y100. So Y100 means this tool will be reaches to this point. So this time this R20 is there. So R20 means it should be complete the circular arc. Arc means that is the arc for anti-clockwise direction. So I have mentioned here anti-clockwise. So that's why you can take G03 X80. So X80 means your point will be reaches at this point. That's why X80, because this point and this point will matches with this. So 80 is there and is 80. Y, what will happen? Y is 100. So that time the point will be reaches or tool will be reaches at point F. Now next point, this tool will be reaches to the F to G. That means what is about G value for X and Y? So X is 100 and X is 0 and Y is 100. So I can write X0, Y 100. So that's why I can write a point at G. Now this tool will be reaches to the H. What is the value of H here? X is 20, X is 0, Y is 20. Y is 20. So I write here G01, X0, Y 20. Now tool will reaches to the this position to this position. What is this position? Actually this is clockwise. So I can write G02 and G02. That's why N010, G02, and this reaches point. That point is X20, X20 and Y0. X20, Y0, and radius is R20. R20, and F is a 40, that is feed rate. So this is about the circular interpolation. So this is in a clockwise direction, that's why I write G02. Now the tool movement will be takes place up to B, and then it should be removed from this point. So then tool will be move Z5, Z plus 5 is there, that's why it should be goes upper side. So there is no contact with the workpiece. And last point is M30, that should be spindles off. So this is regarding the manual part programming for this session. So again I will explain this point because this is important point. Actually the tool moves from A to A. So A to A means from this point to this point. So point number A. So first of all we consider the sequence number block, that is G00, G90. So G00 means what? G00 means your rapid traverse is there. The tool will be not is contact with the workpiece. That's why that tool will be moves in a rapid manner. Then G90 indicates that therefore the absolute dimension is there. Okay, so that in consideration of origin. So whenever the given the dimensions, we can take point of origin over here. So that's why I can take G90. Z10, Z positive means Z positive 10 is there. That means tool is above from the workpiece is about 10 mm. So that's why we can write Z10. The next block is for G00, X0, Y0. X0, Y0 means it reaches to the point number A, and yes is 500, that means spindle speed is about 500. M3. M3 means spindle start at a clockwise direction. Now next term, that is for N003, that means G00, that is the linear interpolation with the linear interpolation can indicates with their own rapid traverse moment. And x20, so x20, so x is direction on that side and y is on that side. So x20 means the tool will be moved from A to B, so that's why I can write x20. Okay, and y will be 0, that's why y will be 0, because point B is there, so B is there, that's why I consider as a y0. Now next block is for 004, that is tool moves from B to C. That's why therefore here the G01 is there. That means G01 means the tool is in contact with workpiece. That's why we write Z minus 20. So Z minus 20. So Z minus 20 means your workpiece cut should be, that cut should be minus 10. Okay, and F is a 100, that is feed rate. So this is linear interpolation, that is G01. Now tool is contact with B point, and the the tool will be moved for B to C. C now. So C, what is the C here? X is about 80 because this total height is 100 and this 20. That's why the point C is about, from this point is about 80, and Y 0. So that Y 0. So G01. So this is the linear interpolation. So tool moves from B to C. Now tool move to the C to D. So what is about this? For the C to D means we are mentioning the point D. So what is the about x-axis? So x is about 100, right? And y is about 20. So I write here G01, x100 and y20, right? So y20 is there. So this is regarding the 6th number block. Now 7th block. Now D point is reaches over here. Now tool moves to the this point, that is up to F point. So from E to F, that time you can write circular interpolation, that is in anti-clockwise direction. So anti-clockwise is there, that's why I can write G03. And the last point, we have to mention the final point. So what is about this point? So this point means your x is about 80 because here total 100, so that's why x is 20 80, and y is about total this 100, so y 100, and radius is r20, and f40, that is feed rate. So this is about the point reaches for the E to F. Now point F to G, what is the G here? G is this, so this is linear interpolation, that's why I can write G01, correct? And here the point defined for x, what is x about? X is about 0 and y is 100, so I write here x is 0, y 100, and G01, that is linear interpolation, their cutter will be moved to straighter manner, that's why I can write G01. Now next block I explained here, that is tool moves from G to H. So therefore H point, we are defining H. What is the H here? X is about 0 and y is about what? 20. So y is about 20. So the tool is reaches to the H point. Now the tool will be moves for H to B. What is this? This is called as circular interpolation, which is in a clockwise direction, right? So clockwise direction means we have to write G02, and this final point means x is about 20 because this radius is 20, right? And y is about 0, so like this, right there G02, because circular interpolation, x is 20, x is 20 means we reaches to B to H, sorry, H to B, so that's why x20 because is 20 here, and y is about 0, so y is about 0, and radius is 20, and feed rate is 40. So this is regarding the manual part programming. And last point, we are to Z, we can take it a track from this contact viewer quiz. So that's why we can take a rapid without rapid traverse, we can take linear intrusion and Z5. So Z5 means the tool will be reached for the top of the surface. Okay, and lastly, the main program starts stop, and the M30 means your spindle will stop. So this is the regarding the manual part programming for the milling machine. So same program we will discuss on Fusion 360. So we are developed the path. So here next part is creating tool path in a CAM environment using Autodesk Fusion 360. So same part we are taking consideration, and here we doing with the software. So here already we are doing with we already we did done with manual part programming. Same part we have to done with our software, that is Fusion 360. Okay, so here operation is counter, that is 2D counter. So that means the tool we move from outer side. That's why it is called as counter operation. Now this is model in a Fusion 360. So first of all we model into the Fusion 360. So that's why we can open this. So first of all we create this model, and then we go for the simulation. Okay, so first of all we draw this component. So for that purpose I write this drawing. So first of all we consider the 100 by 100 mm that rectangle. So here rectangle selection, then center point rectangle. So I write center point rectangle over here, put the value of 100, then tab button press here, then 100, then say OK. So this is OK. Now we go for this point. This is the diameter is 40, so that's why I can take a circle, and from this point I take 40 distance, then take remove of the trim command. So I remove first these two values. After that we move for the drawings. Now here we require a circle, so take fillet command, modify fillet, select these two lines, and here point 20, you can write 20 here, say OK. Then next here we can draw the lines from this 20 and this 20. So I draw first line command here, approximately I draw this, correct. Now we take the dimension, sketch dimension, select this point and this point, we keep it a distance about 20. Then next we take this point and this point, so here we can take then 20 distance. So this is about drawing. Then next command is fillet, sorry, trim. Now we remove this point like this. So this is regarding the drawing. Then finish sketch, and after that we can press the E button, or you can go to the extrude command. So this extrude command we increase up to 10 mm, say OK. So this is about the job. Okay, then this is the regarding job. Now the next point we have to enter into the CAM environment. So for CAM environment we go for design to mode to the CAM environment, that is manufacturing moment. So here we maintain the manufacturing moment, that is the CAM moment. Now we move for the setup, that is CAM setup. So here we create setup, and here we select the setup point, and Z is in a upward direction. So this is the condition. So first of all we enter into the setup. Now we go to the setup, that is new setup, right. Now we go for the machine. So according to our usage we can select, that is for milling purpose. So as we require milling, so we check the library first. So this is the library, and here we recently used that library, this is whole library, and from this we select the milling machines. Okay, so there are number of machines is available according to our usage, you can use this. So first of all we select this machine, that is generic 5-axis AC head table. So this is the selection that more dimensions will be machine from X to 0 mm. So this is the dimension info. Then here the machine tools having 100 tools, then tool change will be 50 seconds. So this is the regarding the tool selection, machine selection, sorry. So after selection of machines, we go to the operation, that is setup type. So here operation is milling, that's why I consider milling. Then model orientation, so here select z-axis, so I consider this z is at the above side, so this is the condition. The next condition is for selected point, so here we select the work coordinate system. Is it clear? Now say for go into the center of the stock, so here stock selection is there. So here I select 1 mm, 1 mm for stock side and 1 mm for top of the side. So this is the regarding the setup condition. Now say OK. So here we have fulfilled the setup condition. So as you mentioned here, the next is the selecting the counter geometry. So here we select the 2D counter, and here we select the tool for that 2D counter. Okay, so 2D counter we have selected here. So for that purpose we enter the 2D, then we enter for 2D counter. So this is 2D counter. Now we enter for the selection of tool. So here also tool will be selected more from the library. So actually library is here. So as per the requirement we can select this tools over here. So if it is milling operation is there, then milling. So our operation is milling. So here number of tools is there. So according to that, here we can select the flat end mill. So flat end mill. So here we are required. We are giving the number of options from the library. So according to your usage, we can select this. So I select 80 mm diameter, and the flute length is 38 mm and overall length is 100 mm. So type is flat end mill. So okay. So here select this and select. So this is the graphical representation. Then select over here. Then tool will be approached at this point. So this is regarding the 2D counter. Now say okay. So this is the selection for the 2D counter. So before that we select this two geometries, right? This selecting the counter geometry, this first and second. So above surface and bottom of the surface. So I select first upper surface, then we go for lower surface. So this is regarding the selection of counter geometry. Now we will select for simulation purpose, say okay. So here we are generating the tool path. Now we move for the generate tool. You can take S here, then simulate path. So for that was I select stock here, and here we can decrease the speed. So here it is contact with the tool, and then we have to remove this whole things from the surface. This is nothing but a 2D counter. So this is the tool cutters each other, and then it should be moving tool in an appropriate manner. So here the 1 mm tool, that 1 mm extra part is there, so that should be removed by this tool. So here it should be totally remove this material. So this is the regarding the 2D counter. Okay, so this is the approach for completing the task. So in a first session we are discussed regarding the manual programming, and here we are setting with the software, that is CAM software. So this is generating path we can save. So here this is regarding the tool path we have generated already here. So this after simulating it should be look like this. Then next, after selecting the post process, so after completing this process we go to the action command, post process. So this is post process, write this. So this block is there. So after you generate this code, so it can create automatic codes. So after, according to your usage or can control unit, we can select the control unit. So here I select Fanuc and then post over here. So after posting we have to save this, and for that purpose we can name it. Okay, so name it save, say okay, say okay. After that it generates the code. So this is the code regarding the CNC mill. Okay, so here I check with this, and here simulation path will be generated like this. So this is generated path over here, and in that information it mentioned here the tool position, X position, Y position, Z positions, spindle speed is there also mentioned, is clear, and their feed rate is there. After that description of 2D counter is there. So it is tool the information is there, 80 mm flat end This is the setup and actual time for 114, that is from time total times. So after verification, volume also require volume is also calculated here, and start volume is how much and ended how much. So this is the regarding the simulation purpose. Say okay. So this is the conditions. Now we have to check out this tool path generated over here, and this tool path generated we have to save directly to the computer, and after that you are performing the operations. So this is two methods we are discussing here. So first is your, this is manual part programming, right? So here discuss the manual part programming here, and this type of tool generated by CAM, that software also, that CAM software is a Fusion CAM. So first of all you model it, then simulate the environment, and after that we get the final post process, that is your content of the code. So this is G code and M codes. So you have to save it, and function is for the item, so for the system. So this is the system you have to feed the program. So this is nothing but a set of instructions with the G preparatory code and miscellaneous code. Okay, so this is the scenario for building operation. Thank you.